Okay, folks. It's a presentation. I'm not going to get into too low-level detail. We look at a bit of C++ code, but it's something I did in spare time in the last couple of years. And let's dive in. So my name is Naughter. I work for a company called UL Transaction Security in Peer Street. I'm a Microsoft MVP in C++ since about 2007, and the presentation is a bit on OpenStreetMap, an introduction to it. It's an open source project, and then a Windows application that I developed that sits on top of it. So that's the talk outline. The main product that our company develops, it's called Asterisk. It's a Windows application, and it's used for EMV testing and validation. It's used in the financial and banking industries. I personally don't have a GitHub account. I just post stuff to my own personal website, which is Naughter.com, and there's about 500,000 lines of source code on my website. Now, I would say that 250,000 of that is machine generated, but it's a nice figure to put on a presentation. A little bit about the background about OpenStreetMap. Maybe some of you have heard of it, maybe some of you haven't heard of it, but it's an open source project. It's based on the model and the success of Wikipedia, and the idea is to produce an unencumbered, license-free map of the world to whatever level of detail you want yourself. Different people will do different things, the obvious things like streets and so on, but you can go totally nuts with it. You can map post boxes, individual trees, you name it, people have done it. There's a website that actually collects all grottos in Ireland. You name it, it's there. So it's a vector database. The basic building blocks are ways, which is a position, a lat long, a node, which is effectively a collection or sequence of ways. So an obvious example would be a street. And then you have relations, which are more complicated concepts, such as a bus route. So a bus route, it may map over many individual ways, which are themselves probably roads. And you can have other examples as well, like administrative and political divisions and so on. It's the canonical representation of the data is XML, but that's obviously not a great language for querying. If the data set you got is like 50 gigabytes or 100 gigabytes in size, so to make it more useful, normally what actually happens is you take that data, and there's open source tools that will actually take that and put it into a database where you can do querying on it and so on. And then there's loads of other open source projects which actually build on that to actually allow you to manipulate the data in millions of different ways. So as of last month, there's actually 4 billion nodes in the database, 470 million ways, and 5 million relations. There's 50,000 active contributors every month, and there's a total of 4.5 million individual contributors in total. The full database size is currently 97 gigabytes in XML and 63 in proto buffers. You can pull that download if you want. It'll take probably 3 or 4 days to import your database on a really, really beefy machine with basically, 100 gigabytes of an SSD or something. It will take a long time. There's loads of other projects that then build on top of OSM or use the OSM data itself. So there's loads of examples. There's editors ID, which is HTML based. JOSM, which is Java based. It's It's more like it kind of presents itself as like something like AutoCAD, where you have the data and you can edit the attributes and so on. So an example of an attribute would be on a way, you'd say something like highway equals tertiary, name equals main street, ref equals R742, max speed equals 50, and so on. And you can apply that on any of the three objects. There's loads of editors for it. There's tools that actually allow you to actually query the data in an SQL-like language. These are all web services. I've got some screen captures of these apps later on. There's a web framework for developing maps that you can embed in your website, which is Leaflet, which is some JavaScript library, which I don't know anything about. And then there's actually end-user things like OSMand, which is a routing navigation application on Android, and that uses the underlying OSM data. So, and you can continuously update the data, so you can get a license for all the world in perpetuity for €10. I use it all the time, and it's a great feeling when you're actually routing over the data that you've actually created yourself. There is other ones like Maps.me, which is it's an up-and-coming competitor to OSMand. It's actually also used in developing countries quite a lot. So where the likes of there wouldn't be government agencies like the OSI in Ireland and Great Britain. So the Irish OpenStreetMap community have actually been actively mapping Lesotho in Africa over the last few years. The Irish, there's about 20-25 active developers or active contributors in the Irish community, and we've actually mapped all the townslands in Ireland over the last few years. So again, if you're interested in genealogy, for example, and you also have an open source bent, then you don't need to pay a license to the OSI for this data. You can actually go to our maps and get all the outlines, the vector outlines of all the data. I've got some screen caps of that as well. It's also been used in a number of humanitarian emergencies. So, for example, the Haiti earthquake, the Nepalese earthquake, and the Ebola outbreak last year.
I've got a question.
Sure, yeah.
How are Irish people mapping Lesotho?
A number of companies have actually provided satellite imagery. So Bing Maps have actually donated all the satellite imagery that they have available to us in basically an agreeable license for OpenStreetMap, and then that's used as a bitmap layer in one of the editors. And that will get you the basics of things like roads, streams, villages, and stuff like that. There's obviously some stuff that you just can't do with aerial imagery, but it's a great start when effectively maybe in a lot of places the map is completely blank. If that's the way we, in the early years here in Ireland and in Britain, the way the project started was Landsat imagery. So really it would only give you rough outlines of roads and things like forests and so on. The resolution was not very good. The better way to do it then is, if you don't have satellite imagery, is to go out with a GPS device, enable tracks on it to collect it as often as possible, say 1 second, and then you can import that GPX file into an editor, and you can then use that effectively tracing the outline of a map, and maybe you've made some audio notes as you're going along as well, like this is road, here's the reference number, that kind of information, and that's where it builds up from. The other nice thing is, for example, if there's a road under construction or the Lewis extension, that would obviously have been surveyed, well, it's in an urban area, so it's nice and simple to do, but things like the bypass down in Wexford, the outline of it is already mapped. Getting closer to the opening dates, people will have got out on their bicycles and literally mapped it with a GPX file. And then when the official opening day occurs, is we literally just change one tag, and all of a sudden the road is moved from marked as construction to as like highway equals motorway, for example. So, and in OSMCtrl, you can literally pick up that update, you know, and they publish about once a month or so, rather than with the likes of, say, commercial providers like Garmin, where you could be 6 to 9 months behind, you know. I've done some screen caps here just to show you, but we can actually just fire it up directly if we're working here. So that's actually the main web page for OpenStreetMap itself. So let's see if it's worthwhile firing up a browser here. So what this is actually just showing you is just a bitmap representation of the data. Underneath the bonnet, the actual data is obviously vector, so this is just a rendering of the data. You can actually see Dublin is very, very well mapped. There was a number of projects that were, a couple of years ago, it was one of the Irish contributors did a project where he wanted to see if he could travel from one side of Dublin to the other side on Bloomsday without encountering a pub. And so he actually wrote some algorithms to actually map all the ways from one side of Dublin to the other to actually determine if that was the case. And then that led to, well, that pub is closed a month ago, or this one is open, so we need to update the map and so on. So that's the website. I promise I will show you some C++ code eventually. That's actually Dublin zoomed in. There is an Irish hosted version, so what that is actually showing you is actually all the boundaries of the townslands and electoral districts in North Wexford. The question, of course, is, well, where do you get all of this data from? You can copy from our survey, because that would be, you know, the whole point of this is not to encumber it with any copyright. So what we actually have available for Ireland is access to old, out of copyright Irish and British urban survey maps. And we can then use that to actually present that bitmap underneath the editor, and then trace out the outlines of all the townslands, and then things like baronies and electoral districts on top of that. Here's another example. This is an online editor, a query engine, where it's basically showing you all the graveyards and cemeteries in County Dublin. People have taken this data and done things like, give me all the McDonald's in America, and then find me the place in the US which is the most furthest away from a McDonald's, and then they went off and hiked to it, you know, and took a video and put it up on YouTube. So, okay, so we're working towards some code here. So how you actually interact with this from a Windows client-side point of view is it presents these images pre-rendered. So each tile corresponds to a certain position on the map. And that was, the concept of that is called Slippy Map, and it comes originally from Google Maps. And the basic idea is you got a URL, you got a certain zoom level, starting at normally 0 up to about 18 or 20. Then you have an X and a Y value, .png. So at a certain zoom level, you can take a Latin long and convert it into an X and a Y, and then request that. And you can actually then stitch all of those images together, and you effectively create a seamless image, which actually is a scrollable, zoomable map. On the OpenStreetMap website itself, the way it actually works is it's imported into a database, and then there's actually a rendering tool called Mapnik, which renders that data. So at low zoom levels, which could correspond to the whole world, for example, it'll pre-render that. But then when you zoom in, it'll actually render that on request, because when you zoom into the highest level, you're up to billions and billions of tiles. So it only makes sense to actually render that when you request it. So at the first zoom level, you have effectively one image, PNG, 256 by 256. And as you zoom in, you get 4 further tiles, which is just an increased representation of it, and you keep going in with each zoom level. And then there's published algorithms for converting from lat and long to these x and y values and vice versa. It just is used its standard McCarthy projection. So here's the application. So let's fire it up. So it's a standard Windows executable. And I'll just turn on the outline so you can actually kind of get a feel for actually how it works. So each one of those is actually a PNG file, and you can obviously zoom in, scroll around and so on. And a double click will actually get you to zoom in and so on.
Excuse me.
Yeah, sorry.
We're not seeing the.
Oh,
Not sure.
I need help.
Is it not that big?
I wonder, maybe it's PowerPoint, maybe it's gone full screen or something. Yeah, maybe it's actually grabbed, hang on a sec. Okay. Oh, right, yeah, well, let me see. Control M. Okay. Yeah? So it's probably multi-monitors. Yeah, let me just see if we can drag it here. There we go. Multi-monitors. Okay. Okay. So you can see the outlines there of each tile, and double click will get you to zoom in. There's a little scroll rows here, so you can actually move around. You use obviously the arrow keys as well. So what this is doing is it's just making web requests to actually pull down the data and then rendering them locally. It's kind of hard to do it when I'm looking at 2 things at once. There we go. Okay, so let's just zoom in a little bit more. There we go. There we go. So eventually when you zoom in, you'll actually start to see a lot of the points of interest being rendered. Okay. And is that the right? Yeah, there we go. Okay. Let me go back to the presentation. Okay. Multi-monitor. There we go. Okay. Okay. It's using MFC, which is a tried and trusted framework. I'm not making any bold claims about it. It's basically the only C++ framework that's available in the Microsoft world for desktop applications. It is x64 and x86. It's derived from an MFC static class. So let's actually look at some source code. There we go. Okay, multi-monitor again. Okay. Wow, this is difficult. file. Oh, less on that side. There we go. Okay. There we go. There's the basic class. So there's your control. It's obviously got things for defines for your PNG files and so on. It does hit testing, so you got the objects in the screen. So when you hit a certain thing on the in the window, it'll either zoom in or scroll and so on. You can put your own objects on top of it. We'll see that in a while. It's got like a scale bar, so it'll show you the current scale, but obviously when you're zoomed out, the scale will change depending on what latitude you got, so it just uses the middle of the map. So the way it actually works is it actually downloads the tile, stores it in just a temporary directory, and then when scrolling around, it will try and retrieve the tile from the file system before it'll go online. So if you're in an offline mode, you'll get just the tiles that you've currently pre-cached on your local file system. The other features it's got is it supports the sensors that are built into Windows. So if you've got a GPS device and you hook up to Windows, depending on the driver support and so on, it'll appear as some form of sensor which you can query. It'll give you the the lat long and so on. But if you want to go a bit lower level, you can actually parse the raw NMEA sentences, which is the standard for GPS devices, directly, and that will give you a lot more detail. So it'll give you like the satellites that are currently being in view, the precision values for how accurate the fix is and so on. You did also see there that it should actually do some animations as you zoom in and out as well. It will do things like rotate the map as well. So that's all done with the graphics card. So there's no software running here. It uses an API on Windows called Direct2D. If you, in the old days of Windows, you would have used a thing called GDI or GDI Plus. Effectively, that was a software implementation, so all your images, your strokes, your fonts, and so on would be objects which are represented by something in the main CPU. The problem with that, of course, is graphics cards have advanced an awful lot since then. And really the way you get the performance is actually for the devices to logically to be implemented on the GPU, so you're not copying from system memory back to a GPU and vice versa. So the API is used is called Direct2D, and those devices are implemented as objects on the graphics card. Even though the graphics card is running in 3D, everything is 3D, the API that's exposed exposes things like canvases, strokes, fonts, images, bitmaps, the usual things, vector graphics, and everyone knows about that. The other thing it does is it does geocoding. So there is web service APIs, again available on the OpenStreetMap stack, that will allow you to do things like convert a location a lat long to an actual, let's call it a postal address of sorts, and then the reverse, which is to say, find me a certain location at find me some object at the current location. So the one is the reverse of the other. So let's see if we can do this here. Quite hard to find my cursor. Yeah. shout when you see the cursor.
Yeah, it's
There we go. Okay. It's kind of disappearing. Okay. Okay. Let's see. Address lookup. There we go. So I'll just click on any location on the map here. And it's made a web service call, given a lat long, a certain bounding rect. And I just, the code just actually creates a little point on that with the actual address from the data. And then we can do the reverse. So again, let me see if I can find here. Sorry, that's the wrong one. It's very hard.
You can see it there. You go.
Yeah, up, down.
No, you can see behind.
Oh, that would be helpful, wouldn't it? Let me see. Sorry, search. Control F. Okay, right. Okay, here we go. Okay, here we go. Pubs in Gorey. Okay, a few pubs in Gorey. So let's just pick the first one. There we go. So it'll put a marker on the location, and then the tooltip for the marker is actually the object. So there, I wrote code to encapsulate that in a nice C++ API, so it basically maps down to a function call, hides all the HTTP calls, and what you get back is a nice struct. So you can do a for loop on it and say, for example, if you looked up at an object and only returned one hit, well, present the dialog just automatically go to it. So that's those two. Okay. The other thing it actually does is it allows you to actually calculate positions. Again, this is going to be very hard, but let me see. Just losing the cursor again, sorry folks. Okay, there we go. Here we go. Okay, keep my eye on the cursor. Okay, I think, is that saying polyline? Good, okay. So I'm going to just drag out there. And what we should see is the length of that and its bearing. And now if you obviously zoomed out a bit, it would give you the proper values. You know, it wouldn't treat the Earth as a sphere, it would do the proper maths. There's a algorithm to convert that represents the Earth as an ellipsoid, and it will calculate the bearing and distance between those 2 points. There is a couple of gotchas. For example, if you're at the North Pole and it says, give me the bearing to the South Pole or any antipodal points, the distance is no problem, but the bearing is, well, any bearing. So it'll just give you back like a north-south value, for example, or an east-west value. And that's called Vincenti's algorithm. So I found an implementation of that online, and it was in C# and just re-implemented it in C++. Okay. I probably could do this online, but realizing how difficult it is, I'll maybe just show you the screen capture. There is a file import or file open option there where you can take a GPX file, which is just a track from a GPS device, and it'll just render it on top of your map. So that's actually how originally OpenStreetMap started here in Ireland. It will do things like it'll look through the whole track segment and find the maximum velocity, and then just use a palette to color code it so that, for example, if you're doing speed limits, you know, for example, if you go from 80 down to 30 or 50, and you're not taking audio notes, for example, you can kind of infer that there's a speed limit there. But a lot of the county councils actually publish their speed limit data with an agreeable non-OSI license, so we can actually take that data and actually put that on our maps. So I've done that for all of County Wexford, and Dublin is pretty well mapped as well, but it's a bit of effort to do. You know, it depends on what you're interested in, of course. It will collect the data from a GPS device and then render it, and the arrow will actually show you the direction in which you're moving, and that circle there represents the precision. So that's just an initial fix, so the size of the precision there is probably 50 or 60 meters or something, yeah. With the sensor API, you don't get that information, so the best it can do is just give you a little triangle. So the code, it uses a Windows API called WinHTTP. It's an equivalent to something like libcurl. It allows you to do asynchronous background downloads, so you can say request a certain URL, and it'll give you notification of the request in a background thread pool, and so it's, you know, obviously if you're doing this in HTML, but we're C++ people, you know, we're masochists, you know, the simple way to do it would be write a website, use a leaflet framework with JavaScript, you get asynchronous callbacks, very simple. But we do it in C++, it's getting simpler, but it's still a bit of work to do properly. There is loads of providers out there for the data, so the OpenStreetMap website just uses a standard style that looks reasonably good, but you know, if you're into golf and you want to highlight all the golf courses, you can actually take the CSS styles, and that's an open source project in its own right, tweak them to emphasize certain attributes that you're interested in. So there's one called Cycle Map. It'll emphasize public transport, it'll have contour lines, and pedestrian footpaths and cycleways, and they'll be highlighted in more detail than the standard OpenStreetMap style. I have talked about the hardware API. It's D2D, it's called. It uses a thing in the Windows world called COM. If you've ever worked with it, you know it's terrible. Every type of object that you have there becomes things like variants, and you got interfaces and vtables, and it's just terrible. But if you want really good performance rendering 2D data, you need to use this API in Windows. So obviously Microsoft Edge uses it, but Chrome and Firefox and Windows now use it as well for their rendering. When I converted the code, there's a code path in it that uses GDI, and then there's an equivalent code path that uses D2D. When I converted over, it was 900% faster. The main reason is if you're dealing with raw bitmaps, again, copying them from system memory to the GPU and backwards and so on, that's what is the performance killer. There's a few other nice things in there. D2D, it's a floating point coordinate space, so it'll do sub-pixel coordinates. So sometimes when you actually drag the map around, you'll actually see the edge of the map or the edge of the tile being anti-aliased and button up against another anti-aliased edge. And sometimes you'll see a very thin line. I'm sure there's some setting I can turn on to actually do that, but it does actually make the things like if you're rendering text and so on an awful lot nicer. Standard features, things you expect, plus minus, you know, zoom in, double click, page up, page down to navigate the map. Yeah, the legend I showed you, there's a crosshairs there to show you the center of the map. The one thing OpenStreetMap does insist on is you do attribute the data. It is unencumbered, it is licensed, but it's not copyrighted. But the do request is if you're going to use that data or present it, that you attribute it correctly. So the little app that I have just attributes it and links off to the wiki for OpenStreetMap. There's also scroll rows and the zoom bar, legend, and so on. Why would you use this? Well, you probably, if you're developing Windows app and you weren't going to do it as a web framework, then you might want to present your own images or data on top of that. So the obvious things would be things like markers. So that was like looking up addresses, lines, polygons, and circles, and so on. It does actually, as I said, do hit testing as well. So the idea is you could drag a rectangle around, say, a GPX file and delete out the middle of it, for example. Supposing you were collecting GPX files and the GPX file always ended at your house and you didn't particularly want that data to be made available, you know, like you could work out where your house is based on your username. You know, you might want to draw a rectangle around all that data and delete that out before you upload the data to OpenStreetMap. You can upload GPX files as well as edit the data in OpenStreetMap. You can do both. There's a screen cap of a few examples. And it has a few other things as well. It integrates the MFC document view architecture, so it gives you a preview and so on as well. It has a little map operations dialog, so it'll tell you things like the width of this rectangle, so it, you know, like at a certain zoom level and so on. And there's a web API to allow you to request all the tiles to be re-rendered. So supposing you just made a big change to some of your data locally and it's not rendering immediately, you can actually force a request on the web API to say, I want this tile to be re-rendered. Normally there's a backlog of a couple of minutes, you know, so you will make an edit, you will literally, within a couple of minutes, see your data live on the OpenStreetMap website. And there's a few links to more stuff. So OpenStreetMap itself, the Irish OSM community, Slippy Maps and the wiki. Naughter is the web API for doing geocoding. Overpass to Perturba was the example of the graveyards in Dublin. Jocelyn is the editor. GPX is the XML file format for GPS logs. NMEA is the standard for GPS. It's a virtual serial port. In the Unix world, you'd probably use something like GPS Babel or GPSD. And then there's a link to Rec2D, and then my own personal links. That's it. Do you have any questions? Yeah?
Is there any metric how the accuracy of OpenStreetMap compares to the, let's say, Google Maps and Microsoft?
Okay. I'm going to repeat. The question was, is there metrics or comparisons of the quality of the data between OpenStreetMap and other map providers such as Google Maps, Bing? I would also include OSI in Ireland. There has been a couple of community contributions where people have actually taken that data. Actually, OSI in the last couple of years have actually started releasing some of their vector data with a usable license. And one person actually took all of our Townsland data and compared it against Northern Ireland and the Republic's Townsland information. And the worst case scenario was maybe some outlines of things like coastal townslands where a beach was either eroded or expanded or land was reclaimed, but it was remarkable, the level of quality, it kind of got down to maybe about 10 meters or so. But I would say the quality of Google Maps data here in Ireland is dreadful. Do not use it for navigating here in Ireland. You will get lost. It's terrible. That's my own personal opinion, but you're free to try it yourself. Obviously, OSI is updated every few years. The quality of that is effectively amazing, right? That's the gold standard, and it's the same in the UK. That's originally where the Ordnance Survey came from, was the British. Ireland was the first country to be effectively mapped to any level of accuracy by the British Army, so hence the word Ordnance Survey. That is the gold standard, but what's actually happened with those organisations in the last couple of years is because of things like OpenStreetMap, they've actually started releasing their data in the public domain. There is the British Ordnance Survey have released quite a lot of their own data into the public domain, and we can actually then use that and check our data against theirs and so on. And that's a campaign that's been running for a good few years. There is certain things that we just won't be able to do, and the example will be air codes and postcodes. It's run by a commercial organisation or a consortium, and they're obviously in it to do their business. They will not be releasing that data into the public domain. We did make some contributions to that when the air code was being the project was actually being ramped up, but it never, 20 or 30 open source developers working in Ireland, they're never going to be able to provide a level of quality that something like a postal code system for a country is going to require. But I'm sure that's what the Encyclopedia Britannica salesmen were saying 20 years ago, before the internet and Wikipedia, and where are they now? So yeah.
Does OpenStreetMap put in fake things into maps? So other mapping cartographers put in fake.
Oh, fake. Oh, you mean
they put in fake things?
Yes, to catch you out. Yes.
Does OpenStreetMap do that? And if not,
no.
But know if somebody is stealing this stuff.
Yes. Yeah, like the Ordnance Survey and the UK Ordnance Survey and the Irish Ordnance Survey are very, very famous for putting in things like magic roundabout, or a close, a name of a location that doesn't exist in reality. And if then that ever appears in any other map, then the obvious thing is that's been copied from effectively a copyright. So no, the whole idea of OpenStreetMap is to map the data, the ground truth. So this obviously gets into politics, so things like Northern Ireland, Londonderry, Ukraine, Crimea, Russia, Turkey, Cyprus. What the community have kind of agreed on is to map what is actually on the ground. So in the case of Cyprus, there will be a demarcation, that is the ground truth. With a place that has multiple names, we have support for things like name and alt name. Things like Derry, Londonderry, it will always be marked as Derry/Londonderry, and then you'll have an alt name and an alt name 1 and so on. But no, we map what's on actually on the real data. Another brilliant example was, we do have a lot of vandalism, but it's very, very quickly eradicated. So it wasn't last week, but a number of years ago, someone thought it was really, really funny to actually start drawing glaciers over all of Ireland, So yeah, it was a great joke, but it lasted 30 minutes and it was reverted immediately, and the account was banned. There is a version control system underneath this, so for every edit, there is effectively a revision history. So, and you have a policy, you can actually ban users and so on. It's a pretty good community. Yeah.
Have you tried to have a Linux version of this?
The question was, have you tried to do a Linux version of this? I am a Microsoft MVP, but I do release some software on my website which will compile in GCC and LLVM. The problem with that would be pretty much all the code in there is using Microsoft technologies. It would be, I wouldn't say start from scratch, but I would have effectively a definition of all the functionality that I would need to rewrite. One thing I might actually do is actually maybe run it on Wine or React OS just to see how it behaves. Like I can turn off D2D. I don't know if that's supported in Wine. Probably is. Is it?
I think so.
Yes.
Yeah.
So I played with Wine recently, and it's quite promising. Like,
Yeah, yeah. Yeah, like I think a recent-ish version of Microsoft Office does run on it, and I'm pretty sure Word uses D2D. So, yeah, that might be something I could look at. At least getting it running in a reasonable way.
So Wine actually offers something called WineLib, and you can link against WineLib, and then
Yeah.
whatever you don't have, you could pull in headers and stuff from Wine, and you could actually offer a standalone application.
Yeah. Okay. Yeah, that's definitely something I could do. Could look at. Yeah. Yeah.
I was at a meeting where people were editing
Yeah.
and there was a representative there from one of the county councils.
Yes.
They
Yeah.
said that actually they dumped the OSI and they're going with this because the OSI wasn't updated fast enough and it didn't cover new states and so on.
Yeah. Yeah. Well, there's a comment, not more a question, but one of the active Irish members on OpenStreetMap. He works for, I think it's Fingal County Council. I've met him at a couple of meetups. He's one of the guys that's actually been pushing for the mapping of Lesotho mostly. But I think he does actually. I think the latest Lewis maps actually are using OpenStreetMap on the actual stops. I need to check that myself. I might check it in the next hour or so. Someone told me that, but the truth, if you want to deal with data which is like who owns this field, you're not ever going to use OpenStreetMap data because we don't have access to that information, the land registry and the OSI. But that's not really what OpenStreetMap is about. It's building a community around this, yeah? Where the organisation actually locally is in the process of actually setting up a chapter. I think there's a meet-up in the next month or so. It's going to be in Dublin somewhere. I'm not sure. It could be in Talk, perhaps?
That's right.
Yeah. I've missed the last couple of meetups, but there is one, I think, the next month or so, but it'll be more setting up a limited company or a corporation or something, so it won't be really a mapathon or anything, but there is a meetup about once a month or so in Talk. It's just behind, I don't know the name of the place, but it's not too far from St. Stephen's Green.
Yeah. It's off Clanbrassil Street.
Clanbrassil Street, yeah. Any other questions?
So I'm afraid we're going to have to kind of cut it.
Okay.
If there's any short question, we can take that, but otherwise we can have to. Sure.
Okay. One last question.
Is the OSM community interested in something akin to Street View?
There is actually, yes, sorry, let me repeat the question. Is the OpenStreetMap community interested in something akin to Street View? And there is a project live, it's called Mapillary, where you can run your dash cam type cameras. You point it out the front of your window as you drive along, maybe one in the back as well, and it will actually run. You upload that MPEG or MP4 file or whatever, and I guess it must be some sort of GPX track along with that, and it will actually tie that data to give you an open source Street View like application. The website is mapillary.org.com. It is I'm pretty sure it's an open source. It's not a commercial organization that builds on top of it. It is a true open source project in its own right. Okay. Thanks, folks.